So in this video I'm going to continue with the practice questions for grade 9 ASP for the end of term 1 exam. We're still talking about objects under free fall, and now we're looking at graphs related to them for a little while. So let's see. Which graph might show the velocity of a ball that is thrown straight up into the air and allowed to fall freely to the ground? So it's gone up and it comes down. So out of the 4 graphs, we need to check the motion. When I throw it up, I am giving it a positive velocity, as we mentioned before. At the highest point, we remember the velocity will be 0 and is coming down and getting faster and faster in the negative velocity. So if I'm going straight up and coming down, I need something which will have a plus, a 0 and a minus for the velocity. These are velocity graphs. Let's look at the first one over here. This is going from 50, that's positive 50, and it's slowing down because there's 0. It reaches 0 and now it's negative, look, minus, and it's getting faster in the minus. Actually, this happens to be the correct answer. It starts with a positive velocity, let me just bring that in here, positive, slowing down, right here, slowing down, reaching 0, that is here, the highest point is here, V is 0, and then what happens? It goes down and gets faster and faster. It's going down faster and faster to the negative side. And I also did mention, if I started at a certain speed, at the same point on the other side, the speed is the same. If this is plus 50 here, it'll be minus 50 here. Maybe plus 30, minus 30. Plus 10, minus 10, 0. Something like that. What's wrong with this one? Well, I started with a negative velocity. Up is positive, so that's the reason why this is wrong. Looking at graph number 3, what's wrong with this one? Well, if you look at it, it did start from the positive, it did slowly go there, but then it finished over here. This is basically only the upwards part. It stopped here. For this graph over here, it stopped at the highest point. It did not mention the last bit, freely falling to the ground, because it has to also come down. That's why this is also wrong. This is half correct. Fine. This one over here, starting from a 0 velocity, that's not true, because I started from a velocity, then it became 0, and then it came back down again, so that's totally wrong. So A is the answer. Over here, what time is it 0? And this is now a displacement graph. So this is the actual path that will take going upwards and coming back down again. Starting from 0, as time goes along, it will go up, 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 reach the highest point, stop, and then come down. So at this graph, the velocity is 0 at the highest point. This is like the shape that I've just drawn here. The displacement graph looks like the actual shape. And you can see from here the highest point is simply 2. That's why we have 2 over there. Over here now we're looking at the graph and deciding what's true about the position, not the position, but the velocity and acceleration about the position. Which one? It's asking about A. You can see it's on its way up and it hasn't reached the top yet, so the velocity itself should be positive. So this would be a positive velocity. That's why C and D can immediately be eliminated. It is either going to be A or B. Obviously the answer key is here, but it's either A or B. Then you can say, alright, so what about acceleration? Well, we know that's gravity. Acceleration is gravity. It's always acting down. All the time, gravity acts down, so it's going to be negative. That's how I know that the velocity is positive, because it's on its way up, and the acceleration is negative. It's always going to be negative. A, B, C, D, acceleration should always be negative. What is true about position B? Where is that? At the top. Velocity, just like over there on the left-hand side, velocity is 0. If velocity is 0, acceleration still minus 9.8 or minus 10, depending on the exam. This is going to be negative, and that's why we have velocity of 0 and negative. Which is true about the speed from A, C, and D? Let's check. There's A, there's C, and there's D. Now, a little trick and a little clue is, the higher up you are, the slower your speed, because clearly it reaches 0 at the top, then gets faster and faster and faster until it hits the ground. So from the top to the bottom, B is 0, and it's asking what's next. So after B, we have C, and then we have A. Remember, this is positive, this is negative. We're just going to see about the values. This is going to be a smaller value than D. The fastest will be at the very bottom, right here, when I throw it. So C is less than A, which is less than D. You can write it greatest to smallest. You would also have B if it asked you for that, because B is 0. You could say D is greater than A, which is greater than C, which is greater than B. This question is saying from where? So this is saying smaller. So I need to find the smallest, and we already know the smallest is C. Smallest being C is here, and that's the only option. C, then A, then D. Let's check. C is smaller than A, smaller than D. That's true. That's why this is the best answer. Very nice. So let's check this. Now we're moving back onto the free fall calculations. Well, it's the equations of motion applied to free fall. I will quickly write that out again for you. V final equals V initial plus AT. These are the three main equations that will help you solve anything in an exam for these free fall questions, or any equations of motion. X equals VIT plus a half AT squared. Obviously that gets replaced with minus gravity. And then we of course have the final one, V final squared equals V initial squared plus 2AX. And if you remember the toolbox, we will have everything we need on the side. V final, V initial, and we will have, what is it, A, T, and X. 1, 2, 3, 4, 5. Out of the 5, again, we only need 3. If we have 3, we can solve for everything. Now, some things that are not given to you in the questions, especially for free fall, they expect you to know it. As soon as you see a word of something being thrown or dropped, or something that tells you that it's going to be in free fall, immediately A is negative 9.8 every time, minus 9.8. Keep it like that and you'll never go wrong. A is always like this. Another thing you need to know is if it mentions its highest point, or if it's dropped, that tells you something about the speeds. In this case, the highest point, remember, it's going up, stops, and comes back down again. At the highest point, V equals 0 every time. So if I started from the top and I dropped something and it falls down, again, V equals 0. So looking at question 22 first, highest point, final speed, that is going to be 0. That's two pieces of information given, well, not given, but inferred. What is given is this, starting speed. Starting speed is 25. Now it's asking for what? It is asking me for how long. It's asking me for time. I need t. I don't need x. So I will choose a formula which has the t and doesn't need x. Well, you can see that second and the third is not good because they both have x inside them. The best option is the first one. I want to find the time. Vf equals Vi plus At. You can put the numbers in and shift solve on your calculator or rearrange. If you were to rearrange, you will just write Vf minus Vi equals, and the A is multiplying with the T, so it becomes divided by A. Just like that. You will write the numbers 25, oh, that's actually not 25, V final, 0 minus 25. I'll write it 0 minus 25 divided by A, negative 9.8. And the minuses cancel, and you will get your answer of 2.5 seconds. And because I started off on this one as well, I drew something. Let's look at this one next. I also mentioned if it's not just reaching its highest point, if it's dropped from a highest point. But if it's dropped and then reaches a final speed, well, that means this is the initial speed. Same thing, V, I, V, F, A, T, and X. Let's see what we have. Dropped initial speed, 0. Gravity already, we know that, minus 9.8. No need to say anything after that. 9.8, always. Final speed, we have it, 20. Well, it's dropped, it's going down, it's falling downwards. So I can say minus 20 in that case. How high was the cliff? So it looks like I need to find X and I don't have a T. I need a formula without t. This one's not good, there's t. This one's not good because it's t, and also it doesn't give me my distance. I need the x. The only option is the third one over here. That's how we will pick this one, and you will say the same thing here. We will do vf squared equals vi squared plus 2ax. Look what happened to that 2ax. Again, either rearrange or put the numbers in shift solve. I showed you how to rearrange. Now let's try shift solve. Let's put the numbers in. Vf squared is minus 20 squared. Now, if you were to do minus 20 squared, you would get an error. Minus times a minus becomes a plus. So actually, you can cancel that minus out anyway. It cancels. Equals Vi squared. Well, that's just going to be 0. 0 squared is just 0. Plus 2 times negative 9.8 times x. I'll leave it as x, 9.8x. Now, you can put this in your calculator to shift solve. You will get an answer of 20 meters. It's only asking for the height. Height is a scalar. That is just a distance. It is not a vector. It did not say position or anything, just height. So it will just be 20. You might get minus 20 as your answer, but it will simply be 20. If you were to rearrange, well, 20 squared, that's just going to be 400 if I am not mistaken. And then I will go into, that's 0, nothing happens. 2 times 9.8, well, I'll take it to the other side and I'll divide it by 2 times 9.8, which is like 19.6 or something. 2 times 9.8. And if you do that, you should get around 20. Actually, it will be exactly 20 because they probably use 10, because 400 divided by 20 would give you 10, right? 400, assuming it's 19.6. If we were to do that, you'll get just under 20. Anyway, the answer is C. Okay, very good. Let's check this next one. Thrown upwards. We have a starting speed. We want the maximum height. We have a mass thrown upwards. Now, is that mass going to help me? I don't know. Let's find out. Maximum height. So, again, it looks like some sort of equations of motion. If I have the 5 things written and I can have 3 filled in, I don't need the mass. Let's see. So what am I going to do? Same thing. Vf, Vi, A, T, X. What do we have now? Initial speed thrown upwards. Initial speed, that is 10. Maximum height. At the maximum height, we've already said it is 0. Acceleration is minus 9.8 every time, so I don't need to even read the question for it. What do I need? Height. I need X. So I don't have T again. And look, 1, 2, 3. I have 3 pieces of information. I can solve it. I need to find a formula again without a height. Looking at the 3, so not without a height, sorry, without a time. It's the same one over here, Vf squared. So I'm doing the exact same thing, solving for x over here. So I don't know if I'm going to repeat the same thing again and again, but I'll write it out. Vf squared equals Vi squared plus 2ax. This time Vf squared is just going to be 0 equals Vi, which is 10 squared, 10 times 10, plus 2 times 9.8 x multiplied by x. And then you will solve for x, same way, okay? Rearrange, shift solve, as you like. If you want me to, I can quickly go ahead and do that, really. It's not an issue, that should be minus, by the way. I'm going to take this across the other side. I will technically have minus 10 squared, but 10 squared, just the minus will cancel. Minus times a minus becomes plus, so that just becomes 100. And what I'm going to do is remove the 2 times 9.8 from the x. They're multiplying, so I will divide by 2 times 9.8. 2 times 9.8, I'll go on again, it'll be minus, but height is a scalar, so it's not so important. I can include it. If you put this in your calculator, you should get just around 5, just under 5. It'll be like minus 5 meters. And of course, being a height, being a scalar, the absolute value will just be 5. So now we're looking at something with the height, and we need to find the time, and we can see that it's dropped a pebble. Okay, let's do the same thing. Vf, Vi, A, T, X. What do we have? Have a height. This time we have an X. That's nice. It's asking us for how long, so I need T. I know 9.8, that's gravity. And Vi, yes, we have Vi, because if it's dropped, starting speed was 0. Now, looking at these, I need T with a displacement or distance and whatever acceleration. So there's no x in this one. I needed to find the t, but the problem is I don't have a vf, so I cannot use the first one. I don't have vf. That means I can't even use the third one either, because I don't have vf. I must use this one. I have the x, I have the starting speed, I need the time, I have acceleration. This is a good one to use. So let's do it. I'm running out of space here, so let me erase all of that. That's already done. And let's continue from here. So I will use the second formula. X equals VIT plus a half AT squared. AT squared. X. What is X? Well, that is just my displacement, which is 5. That's supposed to be a 5. VI is 0. So 0 times time, luckily I don't need to worry about any quadratic equation. 0 times time is just going to be 0. So I can solve for this t over here. Plus a half times negative 9.8 t squared. A half of negative 9.8. So these two are multiplying with the t. Shift solve, you'll get your answer. I've shown you how to do that in a previous video. Otherwise, we can rearrange. I'll go ahead with the rearrange, because if you're going to do shift solve, you can skip on ahead to the next question. If you want to rearrange, because they're multiplying, I will go over and divide it on the other side. It will become a half times negative 9.8. And that will give me t squared. How do I cancel the t? I take the square root. What happened there? I'll take the square root. Once I've done that, you will get your final answer. However, in your calculator, if you have a negative under the square root, it will actually give you an error. So you're going to just remove the minus. It doesn't matter. You'll remove the minus, and once you've done that, you will get your answer, and the time will be 1 second. And that's why the answer is B. So check that yourself. There are a few more questions on this, so it's very straightforward. They've given you the formulas and they've solved it for you, so it's quite self-explanatory. If you throw a ball straight upwards, it'll rise into the air, fall back down to the ground. If you have this speed, how long does it take to reach the top? Well, we've done that already. So how long does it take to reach the top? Exactly the same formula, exactly the same idea. They just wrote G for gravity. And then, yeah, self-explanatory. How far will the ball rise? So now that we're looking for X, we'll take this formula here, this third one, and then we'll go ahead and solve it. I don't want to repeat the same thing over and over again. You can go back to the previous questions, because they are literally solved right here for you. And you can try these again as your own practice to make sure you get the same answer. The way they're written, the answer key might be a little bit different, but your final answer will be the same if you do it my way or if you do it the way written in the answer key. Either way, as long as you understand what you're doing. This video is getting quite long, so I'm actually going to stop there now, and we'll move on to the next lesson, the forces, in the next video. Thank you.